Today we're talking about volume. Volume questions are actually not difficult to understand. So volume basically means the amount of air or stuff that's inside this object. So let's say you have this box over here. So in this box, all you have to do is to find the length, the breadth, and the height. Right? You multiply the three values together, you will find the volume. But those are simple volume questions, and frankly, in PSLE or even in P6, you don't get a lot of questions that simply asks you to find the volume of an object. Sometimes they add a tab, sometimes they add two tabs, and then sometimes for some reason they will have a tab with water coming out. So for this video, we're going to try and see how we can solve these type of questions using simulations. So let's say you have a tank right here with a tap that is dispensing water of 5 liters per minute. What's going to happen is that when the water comes out every minute, the 5 liters of water would fill the tank. So my question now is, if you have a tank which has a capacity of 10 liters and that is the sound of aircraft flying again, how long does it take for the tap to fill the tank? So the answer is actually 2 minutes, because 5 liters per minute, what you do is you take 10 divided by 5, so that would be 2. You can actually look at this from another angle, that is from the tap's point of view. After 2 minutes, 10 liters of water would have flowed out from the tank, from the tap, and it looks like this. Okay, that's on top, the amount of water that's on top of the tank. Now what we're going to see is what happens if we have two taps with each 5 liters per minute of water flowing out. So when you have two taps, in 1 minute, you're going to have 10 liters of water flowing out, because each one of them has got 5 liters, so you add them together, so there will be 10. So now the question is this, using the same tank which has a capacity of 10 liters, how much time does two taps need to fill this tank? Did you get 1 minute? Okay, the answer is now 1 minute, because now you have two taps, each one at 5 liters per minute, and altogether is 10 liters per minute of water flowing out. So you only need 1 minute to fill this tank. So what we're doing now is we're going to take a look at an actual question and see how this concept of rate of flow can be used to solve this particular question. So we have two taps, A and B. They can fill a tank at a rate of 3 liters per minute and 5 liters per minute, as you can see over there. So at first, only tap A was turned on. When the tank was 1/4 filled, tap B was then turned on. So we're going to just simulate this right now. So you can see at the back, what we have is our simulation. Right, so in the simulation, as what is seen here. Okay, so 1/4 of the tank is already filled with water. I know it's a little bit hard to visualize here, but 1/4 is already filled, and then after that, both of the taps were turned on. Let's take a look at the question. You see, tap A, B fill the tank 3 liters, 5 liters per minute, as seen here, 3 liters, 5 liters. And then at first only tap A was turned on. When the tank was 1/4 filled, tap B was then turned on. 6 minutes later, the tank was 7/8 filled with water. So how does it look like? Okay, so 6 minutes later, it's gonna look something like that. Okay, 6 minutes later. Okay, I can't show the full thing, but I can show this. So both of them would have water flowing out rapidly. Push. It's hard to. Okay, so 6 minutes later, exactly 6 minutes later, is filled until something like that. Okay, before that it was only 1/4. So now I hope you can see this. It takes a while to render because I don't have a very fast computer. Right, you can see that how much of it was filled. 6 minutes later, the tank was 7/8 filled. with water. So how much water was there in the tank just before tap B was turned on? Okay, so what we need to find out is 6 minutes later, right? In 6 minutes, right, how much water was actually inside the tank? That is, over here at this point of time, how much water was here? It's 7/8. And then I want to find out 1/4. So let me go to the working part. Just type in so you can all see the working. Okay, so when two of them are working together, we get 8 liters per minute. So 8 liters per minute. So what is the amount of water after how many minutes is that? 6 minutes. Right. So 6 minutes would be equivalent to 6 times 8 lah. So that's 48 liters. Right, so we have 48 liters of water after 6 minutes. And this 48 liters of water is equivalent to 7 out of 8. So I gotta take away 1/4. Right, so 48 liters would be 7/8 minus 1/4, which I'm gonna use my calculator to find. Right, but actually it's not that difficult. So 7/8 is the same as 7/8 minus 2/8, which would be equal to 5 out of 8 liters. Okay, so for the 8 liters is 5 out of 8 of tank. So if 48 liters is 5 over 8 of tank, what is 1/8 of tank? Okay, so 1/8 of tank will be, we take 48 divided by 5, which will be equal to, right, so 1/10 is 9.6 liters. I want to find out what is 1/4, 2 out of 8 of tank, equal to 9.6 times 2. So we get 19.2 liters. Okay, can you see that? So 1/4 of tank is 19.2 liters. Now if we go back to our question again, but the tank was 1/4 filled, so at first there's like 19.2 liters. Yeah. So how much water was there in the tank just before tap B was turned on? So tap B was turned on only after 1/4 of it was filled. So that will be the answer. Yeah. So 19.2 liters. Right. So yeah, that's it. Right. So I think using a simulation is not too difficult to see. Okay. So what we have learned is that the amount of time taken to fill the tank will change based on how many taps, as well as what is the rate of flow of water in the tap. In the next video, what we're going to do is we're going to use this idea to try to help solve some of the more difficult P6 math questions that is related to this volume and tap flows.